When I ask you to solve a quadratic equation, what is it that I'm really asking you to solve for? We talked about this for the past couple weeks. When I ask you to solve quadratic equations, I'm really telling you to find the x-intercepts. And what's another term we can refer to x-intercepts as? The zeros. Or we can also call them, also known as, the roots. So for the past 2 weeks, we spent a lot of time and used different methods to find real roots. So for example, when a parabola actually hits the x-axis on the real number plane. And this week, we're learning how to find the solutions when they are imaginary, or when our parabola doesn't hit the x-axis at all on the real number plane. It hits the x-axis on the imaginary number plane. So for example, if you look at this parabola, it has 2 real solutions, or 2 real zeros. This parabola only has 1 real solution, or 1 real zero. And then this parabola has no real zeros. So instead of having 2 real zeros, it would have 2 imaginary zeros. In order for us to find those imaginary zeros, we have to use the imaginary number I. So remember, the imaginary number I, it's kind of a misnomer. Usually imaginary things don't actually exist. The imaginary number I actually exists. It's a thing. I don't want to say it's real because it's imaginary, but it exists. It's a thing. So remember, the imaginary number I gives us that I squared is equal to I squared is equal to -1. And when you solve for I in that equation, you get that I is equal to the square root of -1. So I squared is equal to -1, and I is equal to the square root of -1. Why do we need the imaginary number I? We need it so we can simplify or take the square root of negative numbers. So we need it to take the square root of negative numbers. So now we're going to solve some quadratic equations that have imaginary solutions. So all 3 of these examples in your notes today are quadratic equations or degree 2 polynomials that do not cross the x-axis on the real number plane. All the solutions will be imaginary. So we're going to learn how to find them. So for the sake of efficiency, we're going to be using the quadratic formula to find our imaginary zeros. And this is how I recommend you find them in general. If you come across an equation that can't be factored, I would just use the quadratic formula. So we have x squared minus 4x plus 5 equals 0. And let's just jump into the quadratic formula. So remember, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals the negative of -4 plus or minus the square root of -4 squared minus 4 times 1 times 5 all over 2 times 1. So I plugged in -4 for the b. I plugged in 1, because this would be 1x squared for a, and then I plugged in 5 for c. So let's start simplifying. So x is equal to, the negative of -4 is 4, plus or minus the square root of -4 squared is 16, and then -4 times 1 is -4, times 5 is -20, all over 2 times 1, which is 2. X equals 4 plus or minus the square root of 16 minus 20 is -4 all over 2. I'm going to come up here. So we have x is equal to 4 plus or minus the square root of, so remember from yesterday when we simplify the square root of a negative, we want to rewrite it as -1 times that number. So -1 times 4 is the same thing as -4. All over 2. So x is equal to 4 plus or minus. Remember, we can replace -1 with I squared. And then 4 is really just 2 times 2. X is equal to 4 plus or minus. The square root of I squared is I. And then we can bring out the 2. And then nothing's left in the radical. So the square root of -4 is actually 2i. All over 2. So this is where we need to be really careful. So do you see how our answer is a fraction here? 4 plus or minus 2i all over 2. To be able to simplify this, the 4 has to be divisible by 2, but you're also dividing the 2i by 2. So we have to be very careful when we simplify this fraction. So we're going to have x is equal to 4 over 2 plus or minus 2i over 2. So instead of having one fraction, I can actually split it into 2 and simplify it from there. And I'm going to have x is equal to 4 divided by 2 is 2, plus or minus 2i divided by 2 would just be I. So we have x equals 2 plus or minus I. And how many answers is that? It's 2 answers. Doesn't that mean the same thing as x equals 2 plus I and x equals 2 minus I? So we have 2 solutions. One of the numbers is 2 plus I and the other is 2 minus I. And just like with variables, we can't simplify those because the 2 and the I can't be combined. All right, let's do example 2. So for example 2, why don't you go ahead and pause the video, plug this into the quadratic formula, give it a shot without me, and then check your work when you're done. So let's go ahead and plug this example into the quadratic formula. So you're going to have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 times 13. So negative 4 times 1 is negative 4. And then 4 times 13 is 52. So negative 52. All over 2 times 1, which is 2. X equals negative 6 plus or minus the square root of 36 minus 52 is negative 16 all over 2. X is equal to negative 6 plus or minus the square root. Isn't negative 16 really negative 1 times 16? So we just rewrite it like that, which helps us because then we can replace that negative 1 with what we know negative 1 is equal to. So negative 1 is equal to I squared all over 2. So x equals negative 6 plus or minus, well, what's the square root of 16? 4. And what's the square root of I squared? I. All over 2. So now we need to split this into 2 fractions. So negative 6 over 2 plus or minus 4i over 2, and then simplify. X is equal to negative 3 plus or minus 2i. Moving on to example 3. So for example 3, go ahead and do this one on your own. Pause the video and then press play when you're ready to check your work. So plugging this into the quadratic formula, you're going to have x is equal to the negative of negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 2, times c, which is 5, all over 2a, so 2 times 2. Let's simplify. The negative of negative 6 is 6 plus or minus the square root of negative 6 squared. It would be positive 36. Negative 4 times 2 is negative 8. Negative 8 times 5 is negative 40. All over 2 times 2, which is 4. X equals 6 plus or minus the square root of 36 minus 40 is negative 4. all over 4. So x is equal to 6 plus or minus the square root of negative 1 times 4 all over 4. What can I replace negative 1 with? I squared. So x is equal to 6 plus or minus the square root of I squared times 4 all over 4. So x is equal to 6 plus or minus the square root of 4 is 2, and then the square root of I squared is I. So I squared 4, the square root of that is just 2I all over 4. Simplify that into two fractions, so 6 over 4 plus or minus 2I over 4. And then simplify 6/4 to 3/2. And then 2I over 4 simplifies to I over 2. And I know that because, let's see, 6 divided by 2 is 3, 4 divided by 2 is 3, 2 divided by 2 is 1, so 1I, and then 4 divided by 2 is just 2. And there we go.